At the end of days, we beckon for salvation, our freedom. Our forefathers sacrificed themselves so that we may see the light of dawn. One by one, taken away by the evil. I am Egg.
I guess this is the end for me.
I wonder which pot I'm going into. The steam pot would be a less painful end.
You are wrong, young'un. Years, I have witnessed the death of countless eggs, their faces of anguish as they're dropped into the fiery pits of hell. Trust my word, young'un. Go to the boiling water pot and you'll meet a happier end.
What? How's that possible?
Think about it. If 1 gram of boiling water touches you, the heat transferred is given by the equation Q equals mc delta T, where m is the mass of the water, c is the specific heat of the liquid water, and delta T is the change in temperature in degrees Celsius. 1 gram is equal to 0.001 kilogram. The specific heat of water is 4,190 joules per kilogram degrees Celsius, and the water drops from the boiling temperature of 100 degrees Celsius down to the room temperature of 25 degrees Celsius, making the change equal to 75 degrees Celsius. That gives us 314 joules.
Take a look at this temperature against energy graph of water. When the amount of kinetic energy is applied to a certain amount of water, the temperature of water will increase. During phase shift, however, temperature does not change despite its intake of energy. Because temperature is understood to be the average kinetic energy of the water molecules, the water must not be gaining kinetic energy, but another kind of energy. Because particles attract each other, the water must gain some potential energy to spread apart further and become gaseous. Once the water has become vapor, it proceeds increasing in temperature again. Menacing hand. 1 gram of steam touches you, the steam has to give off heat to condense into a liquid first.
That extra amount of heat is given by the equation Q equals mHV, where m is the mass of the water and hV is the heat of vaporization of water. Again, the mass is 0.001 kilogram and hV is always equal to 22.6 times 10 to the 5 joules per kilogram. That gives us 2,260 joules. After losing that much heat, the steam condenses into water and releases 314 joules afterwards, making a total heat transfer of 2,574 joules. You can see, the heat released in condensation is far greater than the rest of the heat transferred. 1 gram of steam will burn you with 2,574 joules of heat, whereas 1 gram of boiling water will burn you with 314 joules.
But how come the hand never touches the boiling water but can brush over steam?
That's because the density of the steam is far lower than liquid water. Steam, which is a gas, expands through space rapidly, which means fewer particles hit you at a time. If steam was as dense as water, it would scald you almost 10 times more severely. Trust me, it won't be as different in that enclosed pot.
The boiling pot!